So just like before, we're going to do only 2b right now, and we're going to leave 2a until after we've done our unit circle. So we need to determine the value of cotangent of 12 pi over 5 to the nearest hundredth. Now, we don't have a cotangent button on our calculator, but we know that cotangent of theta is equal to one over tan of theta, because cotangent is the reciprocal of tan. A couple of things that are important. You know how in our previous examples we figured out the ratio for sine, and then when we figured out the ratio for cosecant, its reciprocal, we just flipped it. And we figured out the ratio for tan, and when we figured out the ratio for cotangent, we just flipped it. Okay? It's important to notice the difference in this question. In this question, the 12 pi over 5 isn't the ratio for cotangent. It's the angle. And the definition of cotangent says that cotangent is 1 over tangent, but the thing to notice here is the angle stays the same. The answer will be flipped, but the angle stays the same. So when we go to type this into our calculator, we are going to type 1 over tan of 12 pi over 5. Okay? The most common mistake that students make, I'll write it in red here and then put a big X through it, is students will write into their calculator 5 over 12 pi. They'll flip the angle and not the ratio. So this is bad. Now, when we go to do this in our calculator, 12 pi over 5, is that in radians or degrees? It's in radians. We most likely have our calculator set up in degrees. So you're going to have to switch back and forth. You have to look at your calculator and decide, is this question going to ask me to do things in radians or degrees? And if it's in radians, I go to my mode and I go and I check, and I'm already in radians. But you might have to change it from radians to degrees and push enter. And then when you type it into your calculator, 1 divided by, well, I'm going to use my fraction button. One divided by tan. I'm going to use my fraction button again. 5 over, oh man, 12. I must have got syrup on this calculator. The buttons are sticky. So I can type it exactly like I see it there, 1 over tan of, oh, and I typed it in wrong. Nice, eh? All that talking about not flipping the angle, and I got myself confused. So it'll be 12, sticky button, 12 pi divided by 5. There we go. 3.249. Yeah, yeah, 0.3. It must be Friday, eh? I can't even say numbers in the right order. Did this question say? It said to the hundredth, so that should be decimal 3. Okay, I'm going to check it again. Oh, I think this is a great example. Yes, this is a great example. Love this example. This example is susceptible to the double round. I almost fell into the danger of the double round. What is the double round? It's when you round once, and then you're like, oh, I was supposed to round to 2 decimal places, not 3, and you round again. So if I round once and I got 0.325, how should I round again? I'd get 0.33. But what is my actual answer when I look at my calculator if I would have rounded to 2 decimals originally? Oh, I love this question now. I'm so happy. I'm so happy I could introduce you to the double round. That should actually be 0.32. It ends up being a good day after all those mistakes of saying things wrong, typing in things wrong, rounding it wrong. I get to introduce you to something that you can do wrong. Anyways, so it should be just 0.32 when rounded to the nearest hundredth. All right, so questions we can do after 2b are 6 and 11. And again, I want you to use your calculator for those. There might be something in the question that says you can do it without your calculator. For those ones, we can't do until after our unit circle. But just do them with your calculator. If your answer ends up being 1.73, and you look in the back of the book and they have the square root of 3, and you're like, my answer doesn't match up, type the square root of 3 into your calculator. You get 1.73, and you're like, oh, it is the same. It's just they have an exact number. We haven't figured out how to do that yet for all of these.